Welcome to Around Town, a podcast related to town engineering, the home of civil, construction, and environmental engineering at Iowa State University. Town engineering is a building filled with amazing students, faculty, and staff. Named after George R. Town is filled with study and research destined to impact the world. We will use this podcast to tell stories, inform, and take you around town. Okay, welcome back to Around Town. I'm your host, Anna, and I'm here today with Pitt Des Moines Professor in Civil Engineering, Director of Fast Track, and Co-Director of the Reactor Lab, Dr. Anuj Sharma. Welcome, Anuj.
Hi.
So today we'll be chatting about AI for civil construction and environmental engineering topics, processes, and projects. But before we dive in, can you tell us a little bit about how you first started down the civil engineering track and how you first started using this technology in your work?
Sure. I did my undergrad in civil engineering, and one of the things how I started in civil was that I'm from India originally, and if anyone has traveled the roads in India, they would realize that there is a lot to be done there, and that was one of the motivations to become a part of civil engineering. But as I moved to US, did my master's and PhD, I realized that a lot of decisions were being made by good engineering judgment rather than driven by a lot of data. And that is the reason where we started working with data much more, so the people who are making decisions don't have to just rely on their gut, but use data to make better decisions. So that's how the data came into play. And AI has been around for a long time. So when you have a bunch of data with you and you want to see what patterns are emerging from the data, what are the anomalies coming out of the data, that's where you start using machine learning so that the insights from the data can be drawn, and the person who's making the decision doesn't just have to look at raw data, but what the data,
The conclusions of the data.
the stories the data is telling, essentially.
That's really neat. Thanks for giving us a bit of background. Now let's get into AI. It's such a buzzword right now. A lot of people have an idea of what it is, but as it relates to CCEE, and I think we found that the first is vision-related AI.
There are a lot of definitions of AI out there, but according to what I think AI is essentially a machine-driven model that can help you tell stories with data, essentially, as a human would do if you were looking at graphs and things like that. How we are using vision in civil engineering, there are multiple applications. So one of the common application which we are researching in and developing some prototypes is that, for example, DOTs have few hundred cameras on their roadways and freeways, and right now currently there are operators sitting in traffic management center looking at these cameras. So for example, if they get a call or on Google Maps they see that there is red lane appearing, what they go and try to see is there a crash which is causing that anomaly. What happens is that they have to keep on moving from camera to camera. So by the time they come back to the first camera, it can be 15 minutes. What we want to do is that if a crash happens when they have just moved away from the camera, they get a ping that, oh, by the way, there is something going on in the camera. So that automation of detecting a crash or someone stuck on the side of the road or a debris on the road can be automated using AI, where we are doing it for not just one camera, but all the 500 or 600 cameras, and letting a human drive the decision after they have been pinged that there is something going on.
So the human aspect is still in that process, but it's being supplemented by the AI.
That's correct.
So for the vision-related and camera-based detection, how are they finding those situations? So is it based on like the speed of the cars?
So that is what has changed in recent year. There has been this question is that why is AI becoming much more usable? So previously what used to happen is that if we were doing some image processing on the camera, what we were doing were we were doing background subtraction. So we'll see that, okay, this road shows up every single frame in the camera. Let's remove this road, and then we will have object of interest, and we'll try to detect them that there is a car and there is a motion, and then we'll see that whether that motion looks good or bad. Around 2010, there was a seminal paper which was published where they showed that this detection of a vehicle being present or a track being present can be done much more accurately using something called deep models, which is deep neural network models. And for the first time, it was shown that they can perform really better. So there was this ImageNet challenge which used to happen, and what used to be a seminal paper is that if you improve the detection accuracy by few percentage points, so like if it is 72, then you become 72.2. That's a seminal paper of the year. That year, it jumped by 5 or 6 points. So, like overnight, people understood that this is something that can be used in real world and not just for publishing papers. And today, the accuracy in that challenge is over 95%, which is as good as a human watching that video. And nearly all the papers were submitted are making use of these deep models rather than any other technology. So what it did was that it made it commercially viable to use a technology and which can detect as accurately as a human. Now there are models which you can say, you can just ask a question to a video, say that, what do you look at, what do you see in the scene? Is there a car stuck in the side of the road? And they can actually find that, oh, this frame, there's a car stuck on the side of the road. So the AI has been really, the area has been expanding quite a bit.
It sounds like it's kind of been unlocked.
Yeah.
Like everything is meeting it where it's at right now, and that's...
Yeah, and like we can see those revolutions. So ImageNet was one of them, but then ChatGPT was the second one where people saw that this can do something useful and it can do it well enough that it can be used for practical purposes.
That's actually a perfect transition into our next topic, which most people know what ChatGPT is and how generative AI has kind of impacted the culture here and higher education as a whole. But how can engineers use generative AI day to day reliably?
So yeah, people have been acquainted with ChatGPT because it became such a big deal. But generative AI is a much bigger topic. So it is basically if you have a distribution, statistical distribution, and you wanted to draw samples. It can be images, so basically it can be that I give a statistical sample of all Mozart's paintings, and then I say that create a painting which has a moon in it. The AI can generate it, so that it can be pictorial, or it can be that I have a time series data. These are my detectors, and some data is missing. Can you
fill the gap?
Fill in the gap. So these generative AI models basically are focused towards modeling the distribution of the underlying population, giving the data set, and then a person can ask it to generate different things. So if you can think of that, I have trained a model on all the rap songs, and then I say that create a rap song for me, and it would be able to do it. So for engineers, how it is good is some of the examples I was giving is obviously ChatGPT is really good at improving non-native English users. If they write a page and they want to just give it to ChatGPT and say that write it in a scientific manner, it can produce that. So one of the things which we always talk when we talk to the employers is someone who is getting new to the industry is not able to write good reports. Here it is a way that they can even check for the grammar, they can do better sentence formation, and you can even say that follow a format of a specific previous report. The other place where you can use generative AI is what I was talking about is if I have a video and I want to find what is going on my roadway. So I see that, okay, there is speed which is dropping, but I don't know what exactly is the cause. I can now start asking questions to that video reel that tell me what the problem is, and it will say, oh, it is snowing out there, a truck is stuck on the side of the road, kind of thing. The other place where we have used generative AI is we have a huge number of standards out there for every field. In our field, it is like signal timing manual, highway capacity manual. These are big books, and an engineer is supposed to find a solution which meets the standards set in these books. So usually more experienced civil engineers know exactly which page to look when a problem comes in. But if you are new, you are not.
You don't have the time for the
Or even knowledge, experience.
Time to build the knowledge base.
Yeah. But now what generative AI can do is you can ask a question and it can respond to the question based on the knowledge present in the book, which makes the things more efficient and faster. And hopefully you would not be making some mistakes which you would have done if you didn't look at the manual that well.
That's really cool. What about fictitious results?
So that is an open topic right now in research, but people have built some solutions around it. There is one called RAG solution where you give the ChatGPT or similar engines a document and tell it that only give me answers which are present in this document and tell me the reference page number where this.
It's like they're working on a closed loop instead of
the whole world of knowledge, and it still does a pretty good job. So we already have a website. I was talking about signal timing manual, which we have released to anyone to ask questions to signal timing manual, and it works both ways. People can get the answer, but we also can find out what are the questions people are asking where they cannot find the answers in signal timing manual. So as a traffic engineer, I would like to improve those solutions, improve signal timing manual itself to answer the questions which people are asking.
That sounds like you're collecting the data, but you're also informing the people that need it. So that's a cool tool. Moving on to some specific examples of your research. I know that you're working on a snowplow driving way of collecting the data and improving that process. I mean, living in Iowa, that is such an important part of every winter that we have. So can you give us a little bit of a description of how you're using AI to collect that data and the impacts that you think it could have?
Sure, and I think the best research projects which we do come from the industry itself, instead of just me thinking about what the pain point can be. So this project was actually driven by a maintenance garage supervisor, Rusty, and what his thought was that some of the newer cars have this lane deviation warning, and they also have collision avoidance warning. They have a lot of these snowplow drivers who are working in whiteout conditions, where if you don't clean the road, it has a huge economic downside that the interstate would be closed. But if you let your drivers plow those roads, they are working in like as if they had someone close their eyes and they had to work on it. So that was the big problem, and what the constraints were that we cannot use vision, obviously, because that is not possible in those conditions. So we designed a solution based on GPS and a radar system to do both lane departure warning as well as collision avoidance. The other big thing which we wanted to do is make it possible to implement it today rather than it being very futuristic and be cost effective. We want our solution to be less than 15 grand per truck. So we used technologies where like high-end GPS, where it can find out where you are exactly. But to find out where a person is driving, we need two solutions. One is where you are currently, and also what is the lane markings look like at a very high resolution. And to do that, instead of buying the data, we actually made a few runs to figure out where you should typically be driving, and then if you're deviating too much from there. So even though we have to make runs right now ourselves to generate that map, in future we are thinking these maintenance trucks are also driving when there is no snow. So when they are driving, we can find out that these are the typical lanes they move in, and then when it is snowy condition where the driver cannot see anything, we can use that historical data to see that if they are in lane or not.
Wow.
Yeah.
And when do you think that this technology will be implemented? Has it been so far?
So we have implemented it in our test vehicle, and
Mhm.
now this winter we'll be testing it on a snowplow. So the lane departure was tested in last winter, and now we have included the object collision avoidance as well. Uh, we so there are two things. One is the technical viability of the solution, which we have proved it is technically viable.
Mhm.
The other thing is how to present this information to the driver, because
Mhm.
that is a big thing as well. They're already under a lot of stress and anxiety while driving, and you don't want it to be you want it to be consumable but not overburden them with information. So those are the things which we are trying to tweak and get the inputs from the drivers themselves. So we had this big meeting where everyone came and said that we would like to see this, but we would not like to see that. So we will have another meeting.
The user experience.
The user
aspect.
experience
Yeah.
aspect of the things.
Okay. Then second thing that we talked about in our initial meeting was driver behavior.
Yeah.
And how you're using phone technology to collect data for driver behavior related to medical events and training and things like that. Can you give us a little bit about that?
Yeah. The idea has been out there where it is called naturalistic driving data collection. What people say is that instead of collecting data just at the site when the crash has happened, if we start understanding better how the drivers behave, we will be able to we would be able to reduce the number of crashes which happen. Um, and so what one of our project was looking at is that can you also use that data not only to reduce the crashes but also understand if driver is having some physiological issues. So it can be either related to diabetes, if you have diabetic hyperglycemic or hypoglycemic event happening, whether you are having some indicators are showing that you are having an early onset of mild cognitive impairment. The reason for doing that is there is a literature out there which shows that the driver behaves differently when they are having such events. For example, the driver might overcorrect the risk when they are having a diabetic episode and drive at a lower speed. So if you're at a speed limit of 75 miles per hour, most of the normal driver might drive like 4 or 5 miles per hour over the speed limit, whereas this person who might be having an event might be driving exactly at the speed limit because
like they can feel something's happening.
Something is
so
happening.
they're
Yeah.
gonna overcorrect.
Yeah. So what the idea is one is that can a car detect this going on? That historically they have been driving 5 miles per hour over, and now today they are driving, so they can a warning can be given that right now your car gives you a warning that take a coffee break. You seem to be upset. Similar warning can be given to the driver that maybe you are having an episode. It might be a better idea to take a break. The other thing is it can also do early detection of some of the diseases. So, like if you're always when you're making a left turn, you are always going to the other lane, or you are not able to drive through the parking lot very well. These might be some of the precursors that there is an issue which are beyond a typical aging issues, and you can go ahead and try to get yourself checked, maybe get some medication. The third thing is it is also very important for like teen drivers. What are the common mistakes they are doing, and can we tell them that maybe you are changing lanes very quickly, or you are taking you are driving over the curb and things like that. So the whole idea is, can we use driving as a tool to detect the physiological issues, and to collect, and the idea is where does AI come into picture. So like we can record video, we can record these time series data, but these are petabytes of data. So basically if I'm recording a person every time they drive for 3 months, it's a huge amount of data, and a human to go through that data and visually see what is going on is very difficult. So that's where we train AI models. Tell us all the time the person was distracted, tell us all the time they made a wrong left turn, tell us all the time where they were accelerating or very close to another vehicle. And those things can be done by AI to detect those events what are happening. And then the modeling is that if I have 5 of these events, can I say that this person is more likely to have an MCI than the other person? So that is where AI come into play.
Cool. I have a question about how you train your AI. So when you're telling to analyze this field of data, hours long of recording, how are you defining what they want it to find?
Okay.
So are you providing photos? What does that look like?
So the things, this field is growing so fast that every time I give a presentation, I'm like, man, hopefully there is no other scientific paper which has come out. But previously what used to happen is that if I'm training a video, what I'll do is I will say, I'll mark the frames that this is where the lane incursion has happened, or this is where the snow is on the ground, or this is where I see that the person is smoking a cigarette while driving or something like that. So I had to individually say that this is my image and this is what the event is going on, and train it for a huge amount of data. So that is what's called model training. Once I have a trained model, I'll use it to infer from all the settings. So basically, I might use, say, 10,000 examples of things I'm interested in, train my models, and then infer it on all the data which I have available. What has happened recently is there was something called transfer learning before, which means that people have trained similar models on other data sets of distraction. I can take that data in and just fine tune a little bit. But now what has happened is something called large language models. They have been trained on completely different data sets. Like they have been trained on maybe Wikipedia, and they have been trained on other these big sources of data, but they can perform very well on any topic. So I would just take a model. I don't have to train it. It is called zero-shot inferencing, and I can show it a frame and say that is this person looking in drinking water, basically. And it did a pretty good job without even training out of the box. So now where the field is moving is these large language models are being trained on diverse data sets, and they can be used on very different problems without need for training them at all.
Saves time and money.
Yeah.
In a way.
In a way. It is very difficult to train these models, but once they are trained, they are very flexible.
Cool. Okay, this is my last question. Why now in this industry?
So, as I said, this research has been going on for a long time. Like 1950s, neural network models were available. What was not available is a trifecta of thing. One was the compute was very expensive. So to train such a large model was not physically possible. And what happened, I talked about ImageNet. What happened was they were able to train a huge neural network because GPU was made available, graphical processing unit. GPU was not driven by AI industry. It was driven by gaming industry and cryptocurrency. But it was there, present there, that these people can use that compute engine to train bigger and bigger models. The second thing which happened was the data was easily available. Because of social network, people were just posting their pictures and writing what it is about. So instead of a human annotating 1 million pictures, we were able to download a lot of pictures, and we also knew the description of those. So the data was simultaneously available, which created ImageNet. And the third thing was that there was this big change in access to code. Like a lot of industry open source their codes, a lot of industry open source how people can handle big data. And that happened simultaneously around that range of 2008 to 2010, which led to this AlexNet, which was one of the changing moment for image industry. And this couldn't have happened. All the technologies were out there, but it had to happen simultaneously, and it has to be commercially viable to make it usable. So now what you see is your cell phone has more compute power than the laptop I bought in 2001. So, and the amount of data people are able to send to each other is much easier. So I think that is why it is happening now rather than early on.
That makes sense. Everything's coming together at the same time. Okay. Thank you for giving us some insight into AI and CCEE. You have an event coming up in October, AI for CCEE, which brings together the great minds from the industry, faculty from our department, and some key players in how we bring AI into CCEE. Do you want to talk a little bit about that?
Sure. My vision is that in near future, next 2 to 5 years, everyone AI would become basic skill. It won't be a skill which would be only used by a few academic people. So what we are trying to do is for this AI for CC program is talk with the industry, figure out how can we integrate some of the use of AI when these students are still in classrooms, and when they reach, when the industry gives them a job, they are already trained in what they are supposed to use. And since we are starting this program for the first time, we want to get all the inputs from the industries, where they are seeing the industry moving towards, what applications of AI are better suited in CCEE, and then we can train the workforce according to that. And we would be able to not only provide them a classroom experience, but real world industry projects to make sure that they hit the ground running when they join the workforce.
Cool. And this event is coming this October?
Yes, yep. October 18th is when we are having this event.
Sweet. It'll be in Des Moines, so some Iowans will get a chance to learn more about this.
Sure.
Sweet. Well, thank you for taking the time today, Dr. Sharma.
Thank you so much for inviting me. Thank you.
Thank you. Thanks for tuning in to another episode of Around Town. Feel free to follow us on socials, ISU CCEE. We'll be posting episodes nearly every month, so stay tuned for the next episode.